Ever wondered how to pass rich Python data structures to LLM prompts while keeping the interface clean for both code and MCP clients? We'll see how FastMCP's function prompt from function automatically converts Python types like lists, dictionaries, and floats into LLM-compatible messages. No manual JSON serialization needed. The same render method works whether you're calling prompts directly in Python or through the MCP protocol, always returning properly formatted prompt message, objects ready for the LLM.
This also works for direct calls. Result equals await prompt render. Numbers 1, 2, 3, 4, 5. Metadata source API version 1. Threshold 2.5.
This demonstrates FastMCP's function-to-prompt conversion system, where Python functions become structured LLM interaction templates. The function prompt from function mechanism preserves your function's signature and docstring while handling all type conversion between Python objects and MCP's string-based protocol. The distinctive capability here is automatic bidirectional serialization. Your code works with native Python types, while the system ensures MCP compatibility. The pattern operates by treating your function as both the implementation and the interface specification. When called via render, FastMCP automatically converts complex arguments like lists of numbers or nested dictionaries into protocol-compatible strings, executes your function with proper Python types, then transforms the return value, whether string, message objects, or dictionaries, into standardized prompt message outputs. This dual-mode operation means the same function works identically, whether called directly from Python code or through the MCP protocol. This approach eliminates the friction between structured programming and natural language systems. Developers avoid manual serialization code while maintaining type safety and IDE support, and the system handles all protocol translation automatically. The trade-off is framework dependency, but the benefit is consistent behavior across single-server and multi-server deployments with automatic handling of complex nested structures in both directions. Let's break it down line by line.
This also works for direct calls. Result equals await prompt render.
This shows direct invocation of a function prompt's render method, demonstrating the same conversion logic used when called through FastMCP. The await handles the async operation while automatically serializing all Python data structures, including nested lists and dictionaries, into LLM-compatible messages with no manual conversion required. The method returns a list of prompt message objects, maintaining consistency whether called directly or through the MCP protocol, and works identically across single-server and multi-server clients.
Numbers 1, 2, 3, 4, 5.
This provides a concrete list of integers as test input for the prompt's numbers parameter. The array structure demonstrates how function prompt automatically handles Python collections during render, converting them to LLM-compatible message formats while preserving the original data hierarchy.
Metadata source API version 1.
This passes structured data to a function prompt for automatic conversion to LLM-compatible messages. The render method handles nested Python types, lists, dicts, floats, without manual serialization, returning a list of prompt message objects. Created via function prompt. From function, this maintains the original function signature while enabling both direct calls and MCP protocol usage. The pattern works identically across single-server and multi-server clients.
Threshold 2.5.
This threshold parameter defines a numeric cutoff value for filtering operations within the prompt. Function prompt from function converts Python functions into AA-callable prompts that automatically serialize complex inputs, including nested structures like this dictionary, into LLM-compatible messages. The render method returns a list of prompt message objects, maintaining consistency whether called directly or through MCP protocol. Finalizes the dictionary argument for prompt render, which converts the Python data structures into LLM-compatible messages. Function prompt handles automatic serialization of all nested objects, lists, dictionaries, and primitives, without requiring manual conversion, returning a list of prompt message objects ready for model consumption. This function-to-prompt conversion works identically across direct calls and MCP protocol, supporting single-server and multi-server clients. Function-to-prompt conversion. FastMCP's function prompt from function transforms Python functions into AI-callable prompts, automatically handling argument serialization and message conversion without manual intervention. The render method returns a list of prompt message objects, supporting strings, message objects, or dictionaries as return types from the underlying function. This pattern maintains consistency across single-server and multi-server clients, with automatic serialization handling even deeply nested structures like configuration dictionaries.
The function that never speaks to the model becomes the prompt that needs no translation.